Welcome student. Yesterday we had discussed about the structure of Earth atmosphere. Today we are starting the factors affecting the atmospheric condition. There are three factors affecting atmospheric condition, namely temperature, pressure and humidity. So we will discuss all the three topics separately in detail. Getting well? You see, as far as the question of temperature is concerned, this is temperature. Second factor affecting the atmospheric condition is pressure, and third factor affecting the atmospheric condition is humidity. Humidity means moisture content of the air. Getting well? We will today discuss this factor, that is temperature. Okay. Then after we will discuss pressure, and then after particularly we will discuss humidity. You must keep in mind that temperature and humidity are considered as the active factor and pressure is considered as passive factor. Temperature, pressure and humidity of any area collectively determine the climatic condition as well as seasonal change. That's why it is important to discuss these three factors in detail. Now see, as far as the question of temperature is concerned, okay, temperature. Temperature is concerned. So what is the source of temperature of atmospheric circulation? It is important to identify. You know that there are two sources of energy. One energy is stored in the interior part of the earth. It is referred to the endothermic source of energy. Endothermic source of energy. Okay, because you know that very high temperature condition prevail in the interior part of the earth, and this high temperature condition is due to several factors like presence of radioactive element, friction between Cima and Ife, overlying pressure, rotation and evolution of the earth itself, again conversion of gravitational pull into energy, and emission of magnetic flux are important factors collectively responsible for high temperature condition prevailing in the earth interior. Getting well? So, and second factor is the energy which is received from in the form of solar radiation. So actually one should keep in mind that insolation is the main factor responsible for atmospheric circulation, but it is not the endothermic source of energy. Getting well? So it means whatever atmospheric circulation occur is due to insolation. The meaning of the term insolation is the incoming solar radiation, the part of the sunlight which enter in the atmosphere or fall on the surface is referred to as insolation. So what is the meaning of insolation? Clear? Now see, as far as the question of temperature is concerned, so sun is the major source of energy for the atmospheric circulation. There are several factors, though particularly there are more than 17 parts of the sun, but here we will discuss mainly particularly three parts. Okay, this is the central part of the sun, this is first, this is second zone, this is third zone, and this is fourth one. Getting well? So there are broadly there are four parts of the sun. Sun is medium-sized star. Okay. And you should know that the source of energy of the sun is due to nuclear fusion reaction which proceed in the core. Due to nuclear fusion reaction, energy is generated in every star. Every star possesses their own energy because either nuclear fusion is going on or nuclear fission reaction is going on. In sun, nuclear fusion is considered as the main source of energy. Okay, and this proceed in the core, and hence core is referred to as engine of the sun. Okay, core is considered as the engine of the sun. Getting well? So actually when reaction occur in the core, energy is produced. Okay, and the energy thus produced is actually you see the third layer is referred to as photosphere. Photosphere. Okay. So photosphere is the part of the sun which emit white light. Getting well now? And fourth one is the chromosphere. This is chromosphere, right? Chromosphere. So we have four parts of the sun. First is core. This is referred to as core. Second one is you see whatever energy which is produced in the core get transmitted up to photosphere through convectional mechanism, because actually sun is due to the state of sun is gaseous one, and convection is considered as the best mechanism for the transmission of energy. So that's why zone second is referred to as convectional zone. Convectional zone. Okay. So there are four parts of the sun. One is core of the sun. Second is particularly convectional zone. Third is photosphere, and finally the outermost segment of the sun is referred to as chromosphere. Getting well now? So you see, the energy is emitted by the sun by photosphere, okay, and the outermost part is referred to as chromosphere. Actually, sun emit energy in all the direction. In all the direction, energy is emitted. So out of the total, suppose this is Earth's surface, and this is upper part of Earth atmosphere, okay. So out of the total energy emitted by the sun per unit time, right, है ना? Whatever total amount of energy which is received on the upper part of Earth atmosphere is only 1/2 billionth part. Billionth part. It means upper part of the Earth atmosphere receive only 1/2 billionth part of the total energy emitted by the photosphere. Getting well now? This energy is referred to as global radiation. Global radiation. Okay. What is the meaning of global radiation? The meaning of global radiation or global radiation refers to the total amount of energy, solar radiation, received by the upper part of Earth atmosphere. Again, you see, this is atmosphere here. There exists particularly different gases. Okay, this is referred to as Earth atmosphere, and this part is referred to as vacuum. Getting well now? Again, I am particularly repeating the figure. You see, this is sun. Okay, sun emit energy in all the direction. This is Earth's surface. This is the upper part of Earth atmosphere. Getting well now? This area is vacuum, and this is atmospheric area. Okay, surrounding the Earth from all the sides. Getting well now? So actually, when energy is emitted by the sun, you see, here there is a vacuum. So the best mechanism, or the only mechanism for transmission of energy in vacuum is the radiation process. Getting well now? So that's why energy is emitted in the form of, through, since energy is emitted through radiation process, that's why it is referred to as solar radiation. Why we refer solar energy as the solar radiation, right? And you must keep in mind one thing, the average, there are two types of temperature of any star. One is the temperature of the interior part of the star, central part of the star, and second is the temperature of the outer surface. So normally the temperature of the outer surface of every star, and most of the stars range between 2800 degrees Celsius to 28,000 degrees Celsius. Getting well now? Okay, right? The star whose surface temperature is 2800 degrees Celsius appear reddish. Okay, it will appear reddish in color, and it will appear violet in color, Vanilla Pinala spectrum. Getting well now? So since the surface temperature of sun is around 6000 degrees Celsius, so that's why solar radiation appear yellowish in color. Getting well now? How particularly energy come up to the upper part of Earth atmosphere? It is clear now? It is through the radiation process, and at the same time you see, if this is vacuum area, so there are two types of wave. One is mechanical wave and second is electromagnetic wave. Mechanical wave require medium for propagation for their movement, but electromagnetic wave can propagate even without medium. Getting well now? And solar radiation, propagate even in vacuum. So that's why solar radiation or light is the example of electromagnetic wave. Getting well? Now see, Actually, I said that whatever energy which is emitted by upper surface of the Earth atmosphere, by the photosphere, only 1 upon 2 billionth part is received by the upper part of Earth atmosphere, and this part is referred to as global radiation. Global radiation. So global radiation refers to the total amount of energy which is received by the upper part of Earth atmosphere. Okay, and it is equivalent to 1 upon 2 billionth part of the total energy emitted by the photosphere per unit time. Getting well? Suppose global radiation is 100 unit. I am using unit, not percentage, to be noted. Getting well? So when solar radiation entered inside Earth atmosphere, out of 100 unit, cloud reflect 27 unit of the total solar radiation. Getting well? Again, if dust particle is present, dust particle reflect 6 unit of the total solar radiation, and ice crystal reflect 2 unit of the total solar radiation. Getting well now? It means actually, again you see cloud is the major reflector which reflect 27 unit out of 100 unit. Again you see dust particle reflect 6 unit, and ice crystal reflect 2 unit. Getting well? So it means total reflection is 2 plus 6 plus 27 is equal to 35. Okay, this 35 unit of energy which is reflected back, you see, this 35 unit of energy is neither absorbed by the Earth atmosphere nor the Earth's surface. It gets reflected back. It has no role to play in heating the atmosphere, atmospheric gases as well as Earth's surface. And this energy, this amount is referred to as albedo. ALBEDO. What is the meaning of albedo now? So average albedo is considered as 35, right, according to Tivartha. Though you see it is considered, it range between 33 to 37 unit. Getting well now? And it depends on the condition. It means particularly cloud play important role in reflection. It means you see the area where which is cloudy one, reflection will be more and temperature will be less. And you should know that if you will conduct large scale vegetation, and vegetation will be, the major area is covered by the vegetation. So vegetation favor the cloud formation, and hence when cloud formation will occur, then it will increase the albedo. No? So you see, since albedo is not responsible to increase the temperature of Earth atmosphere as well as the upper part of Earth's surface, so that's why in present scenario, when the entire world is facing the problem of global warming, right, the main objective of environmental manager should be to anyhow to increase albedo, and for this purpose you see forestation is conducted. Getting well now? Forestation will increase the cloud formation, and hence reflection, that is the albedo, will get increased. So what is the actual position? It is clear now? Okay. Now it means particularly you see out of this 100 unit, out of this 100 unit, 35 unit is reflected back. So it means what is the remaining part? 65 unit. So this 65 unit of energy advance in the direction of the Earth. Getting well? And I have already discussed in my previous discussion that the part of Earth atmosphere existing broadly between 15 to 35 kilometers, okay, is dominated by ozone, and hence this part is referred to as ozonosphere. Ozonosphere is the part of a stratosphere, and it possesses the capacity to absorb ultraviolet rays. That's why ozonosphere is referred to as protective umbrella. Getting well? So when this 65 unit of energy advance in the direction of the Earth, 14 unit out of 65 unit get absorbed by ozonosphere. It means you see 65 minus 14 is equal to 51 unit is the remaining part of energy which can advance up to the Earth's surface. Getting well now? Right? Again, see, out of this 51 unit, it means 51 unit is the total amount of energy, right, which is allowed to reach up to the Earth's surface, you can say. And out of this 34 unit, and out of this 51 unit, 34 unit is in the form of direct solar radiation getting well, and remaining 17 unit is in the form of diffused solar radiation. Okay, so it means net energy gained by the Earth's surface is 34 plus 17 is equal to 51. Getting well now? Right? What is the net amount of energy received by the Earth's surface? It is clear now? So it is particularly 51 unit out of 100 unit. You see this calculation. Again, I am repeating, the main source of atmospheric circulation is solar radiation. Sun is medium-sized star where energy is produced in the core due to nuclear fusion reaction, and the energy is transmitted up to the photosphere through convectional mechanism. That's why the intermediate zone is referred to as convection zone. Photosphere is a part of the sun which emit white light, okay, and out of the total energy emitted by the photosphere, only 1/2 billionth part is received by the upper surface of Earth's atmosphere. The total amount of energy which is received by upper surface of Earth's atmosphere is referred to as global radiation. वास्तविक विकिरण के नाम से इसको पुकारते हैं. Getting well? Suppose global radiation is 100 unit. So out of this 100 unit, right, 27 unit get reflected by the cloud, 6 unit is reflected by the dust particle, and 2 unit is reflected by the ice crystal. The total reflected amount of the solar radiation is 35 unit. Now, this 35 unit is referred to as albedo. What is the meaning of albedo? It is clear. Albedo is the total amount of solar radiation which is reflected back without being absorbed by the Earth atmosphere or the Earth's surface. What is the meaning of albedo? It is clear. Total amount of energy which is reflected back either by the Earth's surface or Earth atmosphere. Getting well? What is albedo? Got it now? Now see, it means out of 100 unit, 35 unit was reflected back, and you must keep in mind that albedo play no role in heating the atmosphere or the Earth's surface. Getting well? Now, out of this particularly 65 unit, and because 35 was reflected back now, so remaining is 65. So this, out of this 65 unit, 14 unit which is in the form of ultraviolet rays get absorbed by the ozonosphere, and hence the remaining 51 unit is allowed to reach on the Earth's surface. Getting well now? Out of this 51 unit, 34 unit is in the form of direct solar radiation, and remaining 17 unit is in the form of diffused solar radiation. Getting well? Now there is a term. What is the meaning of diffuse solar radiation? You should clarify one thing. If solar radiation is coming in this direction and its wavelength is lambda, and if d is the diameter of dust particle, getting well now? So actually dust particle play two important roles. Either it causes reflection or causes scattering, right? Depending on the relative condition of relative position of density, diameter as well as lambda. Suppose in first case, if diameter is greater than lambda, then reflection will occur. Okay? When reflection occurs, when diameter is greater than lambda, then reflection occurs. And if diameter is less than lambda, then scattering occurs. Getting well now? If diameter is greater than lambda, then reflection occurs. And if diameter is less than lambda, then scattering occurs. Right? This scattered part of light which come on the Earth's surface is referred to as diffuse solar radiation. What is the meaning of diffuse solar radiation? Getting well now? Right? So this is the condition. How energy gets transmitted up to the upper part of Earth atmosphere, you know, through radiation process, and the amount of solar radiation which come inside the Earth atmosphere is referred to as insolation. The meaning of insolation is referred to as incoming solar radiation. Getting well? Now see, is referred to as incoming solar radiation. So what is incoming solar radiation? became clear now. Now see, actually 34 unit plus 75 unit, 17 unit is equal to 51 unit is actually received by the Earth surface. Now see, what is the utilization of this 51 unit of energy by the Earth surface, whether it directly increases the temperature of the Earth or not. So according to Tivatha, you see, out of 51 unit, if 51 unit is emitted, right, 51 unit, and out of this 51 unit, getting well now, out of this 51 unit, 19 unit is utilized in convectional phenomena, okay, in 9 unit is utilized in evaporization, okay, and 6 unit is consumed in heating the atmospheric gases, getting well. What is the utilization of this 51 unit? So actually out of 51 units, 19 unit is utilized in convectional phenomena, 9 unit particularly is utilized in evaporization, and remaining particularly 6 units is consumed in heating the atmospheric gases. Some climatologists consider that 19 units is in evaporization, right? Whatever will the condition you see, right? 19 plus 9 plus 6, 19 plus 9 plus 6 is equal to 34 unit. It means out of 51 unit received by the Earth surface, it utilizes 34 unit of energy either in convectional process or particularly you see evaporization, right, or in particularly heating the atmospheric gases. So out of this 51, 34 was already utilized, and Trivartha said that the remaining 17 unit of energy, right, 17 unit of energy is lost to the outer space by the Earth's surface in the form of long wave terrestrial radiation. It means 34 plus 17 is equal to 51, right, and is the net loss of energy by the Earth's surface. Getting well? You see, I discussed that 51 unit of energy is received by the Earth's surface, okay, and out of this is net energy gained by the Earth's surface, and out of this 19 unit, 9 unit and 6 unit is utilized in different activity, and the remaining 17 unit is reflected back, is returned back by the Earth's surface to the outer space in the form of long wave terrestrial radiation. So that's why the net loss of energy is 51. Net gain is energy is 51, and net loss of energy is also 51 unit. Getting well now? So it means particularly you see net energy gained is equal to 51 unit, and net energy lost is also 51 unit, right? Earth surface received 51 unit of energy and also lost particularly 51 unit of energy. Now see, Article 112 of the Constitution contains the provision of annual financial statement, right? And this is the constitutional name of budget. Budget is the account of total income and expenditure of the government during one financial year. Getting well now? Right? Here we calculated what is the income. This is 51 unit is the income of the Earth surface, right? Income of energy by the Earth surface, and this 51 unit of energy is the expenditure of energy by the Earth surface. It means you see net energy gained is equal to net energy lost. Getting well now? This is the position of the Earth. Getting well? And this calculation is referred to as heat budget of the Earth. Heat budget of the Earth. Okay? of the earth. Getting well? What is the meaning of heat budget of the earth? Heat budget of the earth is the calculation of the net gain of energy by the earth surface and net loss of energy by the earth surface. This is referred to as heat budget of the earth, this calculation. Now see, as far as the question of budget is concerned, so there are three types of budget. First is, if income is greater than expenditure, then the budget is referred to as surplus budget. Surplus plus budget. Okay. Second, if income is equal to expenditure, then it is referred to as balance budget. Okay. And if income is less than expenditure, then it is referred to as deficit budget. Getting well? So we have three type of budget. One is, first is, if income is greater than expenditure, then it is referred to as surplus budget. If income is equal to expenditure, then it is referred to as balance budget. And when income is less than expenditure, then it is referred to as deficit budget. Getting well now? As far as the question of this calculation is concerned, it is obvious that heat budget of the earth is of balanced nature. So actually this is the character of the heat budget of the earth. Okay? Okay? Getting well? So you see, if the total amount of energy which is received is equal to the total amount of energy which is radiated back, so in this case the budget should be of balanced character. There should not be any change in the temperature condition of the earth surface, or it is clear now. Similarly, you see, now this calculation is the heat budget of the earth. Now see heat budget of earth atmosphere. This is also important aspect. So as far as the question of heat budget of earth atmosphere is concerned, so one have to particularly calculate what is the actual gain of the earth atmosphere. Getting well now? What is the actual gain of the earth atmosphere? So you see, I had said that net gain of the earth atmosphere, right? So I said that, you see, 14 unit, this 19 unit which was utilized in convectional phenomena remained in the atmosphere. This 9 unit which is utilized in evaporization remain in the form of latent heat of evaporization. Okay. And this 6 unit, it is also the gain of the earth atmosphere. Again, while coming on the earth surface, you know that ozonosphere absorbed 14 unit of energy. So this is also the gain of the earth atmosphere. So net gain of the earth atmosphere, you see, right, remained, net gain of the earth atmosphere remained you see, 19 plus 9 plus 6 plus 14. This 19 in condensation, this 9 in evaporization, this 6 in heating the atmospheric gas, and this 14 which was absorbed by the ozonosphere, which was existing in the form of ultraviolet rays. So, and hence the net calculation is 48. It means the earth atmosphere received 48% of the total energy. Okay, 48% of the total energy was absorbed by the earth atmosphere. 48 unit of energy is the net energy gained by earth atmosphere. Okay, and Trivartha stated that the atmosphere gradually returned back this 48 unit of energy to the outer space. The entire 48 unit of energy is returned back. Okay, and back to the outer space according to Trivartha. So what is the actual position? It is clear. Net energy gained is equal to net energy lost. This is the this is again in case of atmosphere. Getting well? So whatever analysis I conducted here is based on the Trivartha analysis. Okay, but you see, Oliver and Hidode was important geographer, because you see, as per Trivartha classification. Since net energy gained is equal to net energy lost, both for the Earth's surface as well as Earth's atmosphere, in this case there should not be any change or alteration in the temperature condition of the Earth's surface. It is clear now. Overall, you see, again, one thing I should particularly, I must clarify the fact that we discussed particularly global concept of the heat budget now, but you see there exists regional concept there, there exists regional aspect of the heat budget also. This is our surface, this is equator, this is 23.5 degree, 23.5 degree north, this is 66.5 degree north, and this is 90 degree north, this is 23.5 degree south and half degree south, and this is 66.5 degree south, and this is 90 degree south, 90 degree south. Getting well now? So this area is referred to as tropical zone. This area is referred to as tropical zone. So why it is referred to as tropical, right? You should understand, I am explaining here one thing. I had said that the heating effect depends on the angle of insolation, which is referred to as climate. Okay? So actually, this zone get vertical insolation at least once in a year. Okay? And these two lines draw the boundary for vertical insolation on the Earth's surface. That's why Tropic of Cancer and Tropic of Capricorn are collectively referred to as line of tropics. Okay? As far as the question of angle of insolation is concerned, so angle of insolation range between angle of insolation range between 0 to 90 degree. But the minimum angle will be 0 degree and maximum angle will be 90 degree. Getting well now? So in tropical zone, the angle of insolation range between 60 to 90. Okay, 60 to 90 is the angle of insolation in tropical zone. That's why it means particularly angle is is more, right? That's why more heating effect is observed in this zone. This is second zone, which is referred to as temperate zone. Okay, this is referred to as tropical. This zone is referred, A zone is tropical zone, B zone is temperate zone. Okay, in both the latitude, home hemisphere. So in temperate zone, the angle of insolation range between 30 to 60 degree. Okay, and in polar zone, the angle of insolation range between 0 to 30 degree here and 0 to 30 degree, 0 to 30 degree. Okay, 30 degree. Getting well now? So in tropical zone, angle of insolation is maximum, ranging between 60 to 90 degree. In temperate zone, angle of insolation range between 30 to 60 degree, and in polar zone, the angle of insolation is range between 0 to 30 degree latitude in both the hemisphere. Getting well now? Right? So actually you see this zone is referred to as tropical, this zone is referred to as temperate in both the hemisphere, and this is referred to as polar zone. So when you will calculate the heat budget in regional context, you will find, I am giving the example, suppose this area is receiving 10 unit of energy, okay, but emit only 8 unit of energy. It means there occur addition of plus 2 unit of energy per unit time. So that's why the temperature in the tropical zone remain high, and it is referred to as surplus energy zone. Surplus. It is referred to as tropical zone. Tropical zone is called surplus energy zone, right? Surplus energy zone. Getting well now? And again, it is referred to as macrothermal zone. Macrothermal, MACRO, macrothermal zone. So what is the name given to tropical zone? It is clear now. First is tropical zone, second is surplus energy zone or energy surplus zone, and third one is macrothermal zone. These are the three names given to the tropical zone. Okay. Again, you see, this is second zone, temperate. In this area, if the Earth's surface receive 8 unit of energy, or suppose only Earth's surface receive, okay, receive Earth's surface get suppose 7 unit of energy, it again particularly emit the same amount of energy, right? So this is the characteristic of temperate zone in both the area. If 7 unit is received, 7 unit is lost, right? So that's why energy is, balance is maintained. So that is the reason why this was a tropical zone, and B zone located, tropical zone exists between 0 to 23 and half degree north and south, okay, and temperate zone exists between 23 and half to 66 and half degree north and south. So this temperate zone is referred to as energy balance zone. Getting well? Or mesothermal zone. Okay. So what is the basic difference between tropical zone and temperate zone? It is clear. In tropical zone is energy surplus zone. That's why energy remain high. Temperate zone is balance energy zone. Getting well? And you see polar zone, in polar zone, if polar zone receive 4 unit of energy, it emits 6 unit of energy. That's why there occurred reduction in the temperature. No? That's why there occur reduction in temperature. So that's why polar zone is referred to as, deficit energy zone, right? Polar zone. For polar zone we use the term deficit energy zone. Getting well now? Or microthermal zone, and it exists between 66 and half degree to 90 degree north and south in both the hemisphere. Okay. So on the basis of heat measure, we have 3 parts on the surface. One is tropical zone, which is energy surplus zone, right? Second is temperate zone, which is energy balance zone, and third one is polar zone, which is referred to as deficit energy zone. So we have 3 type of thermal zone on the Earth's surface. Get well now? So this is regional concept of heat budget on the Earth's surface, right? Now see, actually Oliver and Hidode were 2 important geographers. Oliver and Hidode were 2 important geographers who stated that counter radiation play a more important role in hitting the Earth's surface as compared to that of Earth's atmosphere. Who stated? Oliver and Hidode, right? Oliver and Hidode.